Good morning. Um,
There is some
so
action for
today
the spinners out
we
there. We
are
saw
going
Mimi
to
Kerr,
start with
obviously. We've
the
seen it turn it both
projects.
ways.
Okay, I told you right
Unusual
yesterday
not
we
to see her
have
turn
some
a ball given the
placement
amount of revs that
openings.
she puts on
Okay,
it, but some of
so
those darting back now
from today
from a
onwards we will take
Gujarat
the
Giants
daily
perspective.
mock
They will
interview for you.
hope
Try
dearly
to
that
be
that continues,
available.
given
Okay,
that wealth of
not
spinners they have at
only in
their
the evening
disposal.
sessions, be available in the morning timings also. Okay,
And I think they
morning
still
10
have to
o'clock
score
to
runs.
evening 6 o'clock.
And
Any time
perhaps
is
even
fine for us.
Amanjot
Okay,
has
first
world
of all, we
titles, but
need to
Amulya Kerr
push
has two.
from our
Vaishnavi Sharma has two to
batches.
go.
Okay, because
4 overs of
actually in
spin
our
ball with
batches
Haley Matthews in the
training is
second
not
over.
completed. It is present UVM is going on, right? So that's why I'm taking the resumes from outside people. But first of all, I want to push from our batches. Okay, so take this whole week
And the umpire's
time
just having a
for
discussion.
risk processor, router
Mukesh Garg, I'm
project,
not sure
and
what they're
round
about.
robin orbiter.
Use the
Yesterday I
bowlers.
have
Like
shared
to
the
see
link
Hayley
for
Matthews
the
bowl a
round
few
robin
more overs.
orbiter. Okay, if you want more clarity on that project, I can discuss this whole
Takes a little
week. We
while
are
as well to get some
available
confidence
for
back in your
you
shoulder after
from
you've had a
morning
little bit of
10
work
to
put into it.
evening 8 o'clock. Okay, we need to crack
Big
these
appeal. There's a
interviews.
spun
That's
two
it.
match.
Whatever the doubts you have, these 10 days we are available for you from
Mukesh
morning
Garg
to
is looking down,
evening.
going, "This might be nice for my bowling,
Okay,
but not so nice for
just
my batting."
I need the concentration from your side. Whatever the
They've done it.
we have discussed till
Theatrically,
now,
they've done it.
at least be very clear with the theory concepts. Okay, ask the doubts. Mentors are available. Okay, we will complete the project, both the risk project and router
To the
project this
umpire
week.
director, we
And
have a player's review
next
for
coming
leg before
Saturday,
given
Sunday,
not
I
out.
will
It's a
discuss
fair
UPM,
element. Can we start with front on,
full
please?
test bench architecture with the more designs. Okay, mostly we send the resume tomorrow. Everyone share the resume by today. If we send the resume by tomorrow, we will get the
Just play
update
this
within
once
a
more.
week. Okay, so you can utilize, maybe I can't tell you, within 4 to
Appears
5
to be
days also
gap,
we
but
may
can I
get the
confirm this with
update.
Ultra
Okay,
Edge?
so that's why take a whole this 10 days, put for the revision from Verilog system, Verilog UVM project protocols.
Satisfied?
Okay,
It's a flat line when
so
the ball
from
passes
morning
the
to
bat.
evening we are
Play true to the
available.
patch.
Okay, that's what I want to say.
Thank you. Can we move to ball tracking when
So
ready?
CB is going to start with the processor. Processor, first of all, he will explain everything clearly. What is mean by risk processor? What
Pitching
are the
outside off,
pipeline
if I can
stages
find
and
wickets in the right spot.
instruction set
Thank you.
architecture, and how you
Turf
even
It's
pitch
right
design
pull
code is
there.
indicator
very
is
That has
not
important in
really
visible.
risk.
ragged off the
Okay,
wicket.
so whatever we are discussing in
I think that's a
here,
pretty good
try to
decision.
put those
And
main
the reason
important
is it
points
has
in a
done a
resume.
lot. And I
Okay,
know
yesterday I have
that
shared,
Gardner
right,
was
how
deep in a
to put
crease
the
this hitter on the
projects.
back leg.
Okay,
On
just
first
you
look,
no
it
need
did
to
look close,
mention
but I think
the
when it turns that
client
much, there's a
name,
lot of
all these
doubt there.
things. Okay, just put the
And she might
project
think
name,
she's just
the
escaped with one.
description of
Ash
the
Gardner.
project, and your role
He's taken all that
responsibility in
information
that
in when she's
project.
bowling
Okay,
daggers.
suppose UART is
A
there.
couple of good overs
UART we
plugged together
totally
there from
worked in
Mumbai.
the RTL design. Okay, you need to write like we have
Dangerous approach
developed.
now. Still
My
to go back to use
responsibility
that
is
extra bit
to
of spin.
understand the specification of
Only seven
your
for 3.
protocol, and um, developing the blocks like transmitter, receiver,
Well, the top
baud
of the
rate
wristwatch
generator.
means that
Worked
it's
on the
time
baud
for
rate
a Seat
generator
Tyres
at some
strategic
frequency.
timeout.
Worked on the baud rate generator at that particular 1125 00 something baud rates are there, right? Just those mention that type of points. Okay, because we have discussed everything clearly. Coming to the I2C protocol, you can write like develop the whole test bench architecture in system Verilog and design the frame format of I2C protocol, and check the conditions of start and stop conditions. Okay, by using the test scenarios, develop the test plan for APB protocol. Okay, even for AHB also, design the whole AHB protocol in burst transfers, the increment and wrap, even single transfer designed using RTL, and develop the UVM test cases, and these type of codes also are there with you. Okay, so try to mention all the points what you did in AHB. We have developed the whole UVM architecture. We designed driver logic, scoreboard logic, RTL design for AHP. If you go with the AXA protocol, whole VIP we have developed by using a multi-master, multi-slave, two master, two slaves. And I have shown you the test cases also, what test cases we have verified. Write the test cases. We have verified these test cases. I will show you, wait.
ये क्या खेल रहे हो आप?
किस्मत को घुमाने की कोशिश।
छोड़ो ये टाइम पास गेम और खेलो नए गेम्स।
ओह,
खेलो MP2ism प्रेजेंट्स जीतो दंडनादन के नए गेम्स, जहां विमेंस T20 लीग के मैचेस के दौरान जीतो टैब पे नए गेम्स खेलकर आप जीत सकते हैं ढेर सारे इनाम और MP2ism के ट्रैवल वाउचर्स पाने का मौका।
तो MP में घूमने के लिए क्या-क्या है?
वो सब कुछ जो दिल चाहे।
In AXI protocol, we have worked on this whole test bench VIP. Okay, here there is a test plan. You can mention all these points. You have worked, we have created the test cases for fixed, done, increment, wrap, aligned, unaligned, transfers, outstanding, multiple order transaction. These are very important. Outstanding, multiple order, multiple outstanding transaction, out of order. Okay. The response, the slave response signals are verified. Okay, created the virtual sequence for the AXI by using the number of master sequence and the slave sequences. We have developed the virtual sequence. Whenever they get asked the question, you need to explain very clearly. Okay, you need to explain like a story. Okay, when you will explain like a story, whenever you get the concept, clear concept, then only you can explain like a story. Okay, if someone asks what is the use of virtual sequence or how the physical sequence is connected to the virtual and how the physical sequences are connected to the virtual sequencer. What is the use of virtual sequencer? First of all, we already discussed. Whenever there are multiple number of sequences, without connecting an individual sequence to the driver, we are connecting whole sequences to one virtual sequencer, all physical sequencer to the virtual sequencer. Okay, so how that virtual sequence is connected to the normal physical sequence? I already shown you the code, how the virtual sequence connected to the normal sequence.
It's just something that provides a spark.
You can explain. No one will ask you to write the program in UVM because you can't write whole program, whole UVM architecture. Okay, so you need to explain. I already told you how virtual sequences we need to connect. First of all, phases is the important concept in UVM. Okay, everyone understand what is meant by build phase. Build phase means we just create the components there. Connect phase means we connect the components using TLM boards. Again here TLM, what is meant by TLM concept? How the TLM is differentiate with the mailbox concept. What is the concept in mailbox concept in System Verilog, and why we are moving to TLM port? What are the major rules we need to follow in TLM, from connecting the consumer to producer, producer to consumer, where we get the try put, try get code, get put code, get next item, I mean put implementation for target. These are very clearly you need to understand. Okay, I don't know what you do. You need to spend this whole week for UVM. Okay, revise all the sessions. You must have very good clarity on each concept. I'm not asking about the you need to write the program and all. System Verilog, you need to write the program. How the constraints are written, how randomization are written, how the coverage. Today evening I am going to discuss the coverage also. Okay, maximum today evening I will complete the coverage. I will take extra time and I will complete the coverage. Okay, so whatever UVM we have discussed, you must have every concept clear cut. Okay, just spend whole 16 hours or 15 hours, I don't know. You need to spend whole week for UVM protocols projects. Okay, in resume you need to mention for AXI protocol whole VIP development. You have involved in the VIP development and created the test cases, test plan for these scenarios. Okay, and how
Because you can
you
hear that off
created
the
the
bat,
test
that sort
cases
of
for
crack
these
off the
scenarios.
bat.
But
It is the
once you
shift
go
we're looking
through the
for
coding
Giants.
for sequence, in sequence we
Yeah,
have all
they
test
require a
cases.
lot
See,
more of these.
base sequence, XI slave
Push
slave
the
side base
run rate up,
sequence is there,
get to a
RAN
respective
sequence is
total,
there,
to a fighting
and
total.
here
Skipper Ashley Gardner.
in a slave side only the two sequences are there. If you
That's
go
the
to
longest part of
master
the ground.
slave side, you will
You know, it's
have
gone 70
these.
metres. She is hitting with the spin, so she's gambled a little bit, but it's an area of
Master
great strength
sequence
for
side,
Gardner.
you will have the base
Which then
sequence,
prompts
RAN
a slight change
sequence,
in angle
fixed bus
for Hayley
sequence,
Matthews. Coming
increment
round the
bus
wicket.
sequence,
No change
wrap
in the
bus
onside
sequence.
field.
Okay, so you need to
It
have
should
at
be
least
flat into the
theory.
heel here.
Okay, you need to talk
And it is.
according to that.
Great
Okay,
gap.
they will check
Outstanding
how
start to
you
the
are
over 10 off the first two.
conceptually in depth. Just they will check in your
She was
voice
expecting her to
itself,
be more
how you
flatter
are
in her
explaining
trajectory.
the
Ashley
concept.
Gardner
As I
usually
told you, need
step
to
out,
explain like a
waiting for
story.
it a little
Okay,
shorter.
all the concepts. Whenever you
Delivery,
get
and this
more
time
clarity on that,
gets
then
it
only
on
you
the
can
pads
explain
and
in
makes the
this
most
in
of
that
it.
way.
Getting through
Okay,
the fine leg.
so take time this whole week. Tomorrow we are going to share the
You've actually
resume.
got to push that a
Maximum
little
your
wider.
resumes
You've got
will
to throw that on around off
qualify.
stump.
Why?
If there is
Because they
turn there,
have
you've got
total
to stick it
15
just about
requirement
on
as
the
of
off
now.
stump.
Okay, so
About there.
maximum your resume will
Unfortunately,
qualify
when you're
if you
in the
prepare
mood
the
as Ash
resume
Gardner is
properly, whatever
seemingly,
I said. Okay, 5 protocols
she's
must be
decided to
there
press the button.
as I shared to you.
G for goal, and she picks up another boundary.
Well, that was right in the slot for Ashley Gardner. A good stride and over the
I already
short
shared
mid
in the
wicket in the circle. It's the best area that you can pick right in the gap.
okay, just mention the
Quite interesting
projects
actually,
like
Ash
this.
Gardner versus off spin
You
this season. She's only
didn't
striking
have
at
this
107,
project, just
which is
remove.
quite low and being dismissed a couple
Next,
of times. One thing
processor
she hasn't done, I
verification.
think she's hit a
Okay.
single run into the
And
offside. Everything else to the off spin has
DMA
been into
also
the leg
not
side.
required. Router project and AXI
All
VIP
the pace
development.
off. She took
Like
all
that,
the time to be able to
Project
just
1,
stand there and see
Project
where do
2,
I hit this
Project
one.
3, Project 4,
And 50
Project
partnership comes
5.
up
You need to
quick
put
time.
UART, I2C, APP,
Yes,
AHP,
oh, we
AXI.
can see
Detailed
the
explanation,
momentum
just
shift
2 points.
for Gujarat
Like
Giants.
this, 2
This is
points
that
for AXI
big
also,
over
your
seam
role
line.
and
18 so
responsibilities.
far in 4
And
balls.
project 3 projects. Project 1 should be risk processor. Project 2 should be round robin orbitals. Project 3 should be project 2 should be router project. Project 3 round robin orbital. Project 4, or you can mention like a protocol 1. Your
18 runs off this
detailed
over so
description, only technical description. We have worked on baud rate generator, transmitter and receiving receivers
There
are
you go.
working at this type frequency.
Seeing
Just
the
design
softness
the
ground isn't there's
transmitter
one or
and
two overs you
receiver
go,
block of
take it for
your
20 plus,
yacht
that's how you get
and
that shift,
good
that's how you
understanding of frame
either
format
chase
of
down a
yacht
score,
entire
really separate
specification
yourself
and what
from
frequency it
150
is
to a
working
170.
in I2C protocol. Develop the system Verilog test bench architecture and design the RTL design of
So
frame
I'll have the
format
strike.
and
Thank
check
you
the
very much.
conditions of
Damage is done.
start
19
and start
runs off of the best
in
one so
I2C.
far.
Okay,
125 for 3.
like that in APB. Design the FSM.
कोई कूल डाउन सजेस्ट करो ना जो सोशली
Written,
कॉन्शियस
check the logic in the scoreboard for select and enable signal, write data and read data signal, design the scoreboard and driver accordingly, like that major points. In AHP, we design the RTL for the burst transfers, what are the burst transfer conditions are there, and all test bench architecture. In UVM test bench architecture, what you did, like that AXI protocol. Okay, whatever I shown you. Like that risk processor, 5-stage, good understanding on the 5-stage pipeline risk processor and instruction set architecture and the CB explain these stall and bypass also. Okay, these are stall and bypass mechanisms also important in risk processor. Okay, just mention those and verified
19 runs
in
conceded
RTL
at that.
design. He will explain all the blocks:
Just a reminder as
fetch
to
stage,
when
decode
the
stage,
DC was up
execute
against
stage, write
Gujarat
back
Giants,
stage.
Chinel Henry
Okay, you
conceded
need to
15
mention
in
in
that last
the
over against the
like
Giants, and
develop the
Tanuja Tanwar
RTL
got
design for
21
whole
of
5-stage
11
pipeline
deliveries, and
architecture,
that
hardware
helped
using
Gujarat
Verilog
Giants in that
HDL
last game.
and verified using the system Verilog. Okay, for router project I have mentioned here. If you want to mention some more points, you can. We are doing the router and round robin project in UVM. Okay,
She's
so
on top
total
here.
8
Ashley Garner
projects
here.
list you need to mention.
Had a good over against
Okay, total 8 projects listed.
Hayley Matthews, and now
Okay.
clubbing it through the
Clear?
offside, making room for herself.
Any doubts
And
till
look
here?
at the powerful hit.
Yes, ma'am. Like,
Not the easiest of
whenever
shots
I'm
to play
explaining
when
the
you're looking to
project,
play it
they are
powerfully,
also need to
but
mention
she's done
to
it
the
really
link
well.
also, not there. Mention.
I
Like,
wouldn't
GitHub
mind
link.
bouncer here. Just a
GitHub
change
link.
up of length.
If you have GitHub link, you can mention or else no.
Gets through. It's raining
If you
boundaries
if
for
you
the
have
Gujarat Giants.
your own GitHub link, GitHub
great qualification.
account,
And Ashley
you
Garner
can
making
put that
full use of
link.
it.
No problem.
She was
Even
aware
if you
of the
don't
fielders
put
being inside the
also, it's
circle on the
okay.
offside.
The
Behind
router
square,
and
and she
also
was
not
looking for the gap.
So, like,
And
whatever
she
I did, that
found
one
the
I
gap
put,
as
and
well.
others just simply right.
Gonna push him out
Router
maybe on the
project
bouncer
and
as
Disc
it is a
Processor
shorter
project
boundary
both will
outside,
complete this
51
week.
metres. Just looking at the moment, pace off, but really trying to rip it down into
If
the
you
wicket to
don't
get it
want
holding
to
in.
put router
He's just
project,
holding
your
his shape
ish.
long enough
Round
here,
robin
Gardner.
orbiter you can put. Or else if you have any other project previously, if you worked on any VLSA project, you can
She
put
heard you,
those.
Katie Martin.
Higher WV, a little higher.
Okay,
Speaking of height.
so he will start
Time a little bit at the start,
today.
had a plan,
The
changed
Disc
her approach to the
Processor
spin, say, you know
maximum
what?
today, Monday, Tuesday, Wednesday.
Into them as
In
quick
these
as I
4
can.
days,
So
you will
Hayley
get the
Matthews, she put
clarity.
19 on.
Okay,
She just
and
manipulated
even if
around
you
the
have
ground.
any doubts, you can
And for
ask
me, that would
anytime.
have been
As I
clean,
told, we are
shot in the middle
available
of the
from
bat.
morning 10 to evening 8 o'clock
46 of
for
26
this
and
whole
real
10
good
days.
position over the last couple of overs.
Okay,
She's been a good catalyst for the
yes,
Giants.
CB, you can
Ashley Garner.
continue.
She's
Yes,
played
ma'am. Thank
according
you.
to the situation, and she's always up the ante whenever it
Hello,
was required.
my voice is audible?
The runs keep coming for the Giants.
Hello.
Is this a game-changing over?
Yes,
Okay, thank you. Okay, now I will share my screen.
Reading the situation, knowing
And
when
before
to up
that,
the ante is one thing, but doing
see,
it
the
so
plan is
consistently is another thing.
today I will complete
And this is why she's
theoretical
so
part,
dangerous.
okay? That
Making
PPT
room
and
for
all.
herself, she can
Then
hit
one
along
day
the
we will
ground, she
take
can
for
go
design.
over the
What are the
infield,
designs? And it
and
is of
that's what makes
very
it
Laguna,
very
no?
difficult
So
for the bowlers.
what are the designs? What are the blocks we used?
You always
And
looking at
we
those
have some
double-figure overs,
instruction
don't you?
fetch
The
unit,
18,
instruction
the
memory
20,
unit.
that's how
We
you
have
really get a
ALU
shift
data
in
box. We have
momentum in
register
innings.
file and all. How it is
Anyway,
created,
Mumbai, stopping
like
this
that we
is
will
picking
see
up a
one day.
wicket.
Okay, we take one day for design and one day for verification. If we can't complete within these 3 days, we
34
may
in the last
extend
11
up to one
deliveries.
more day. Okay, this is the plan. And then we will move on to router project.
They just
In
keep
router
coming.
also we have concepts like we
Boundary
use
after
FIFO,
boundary.
we have
These
synchronizer,
are the last
registers,
couple of
and we
overs that
have
the Gujarat Giants
our
was
own
actually
FSM.
waiting for.
Okay,
And they've
in
come
router
about
project
for
we
them
use
in a
FSM
must-win
to define the
contest.
states. Like that, for
Playing
router
with
also
such
we take
mastery
one day
behind square
for
on the offside,
theoretical part and
and she's
PPTs,
finding
and
the
one
gap,
day for
clearing the
design
infield,
and one day for
absolutely no
verification.
problem.
That
Making room
verification
for
will be
herself. Ismail does well to
will
follow her,
be
but
used of
still,
system Verilog
Ashley
or
Gardner wins
UVM.
that battle.
Okay, I will tell you, and I have some materials also,
Quite
extra
often she'll
materials,
close out an
and we
over
will
with a
share
Yorker.
that also,
One of
and
the
I will share
best
the PPT
bowlers
as well.
of a Yorker
Okay,
going around
as
in
of
world
now I will
cricket.
start my
Link hasn't worked here. The shorter
PPT
ball got
presentation.
just a single. Gonna try and clean her up. Just get out of this over.
– 19 in the last over, 17 in this over, 142 for 3.
Okay, my screen is visible now.
महंगी होगी ना
I am sharing.
7,000 रुपए से कम
My
में
screen is
खरीदा है
visible now.
और 90 पैसे पर
Yes.
किलोमीटर पे चलती
Yes.
है
Can you please
VX2 बदलते इंडिया का
increase the
स्कूटर
font
e-scooter।
size a bit?
I just really
Okay,
feel like
okay.
things are going to be different this time.
I'm willing to forgive you after everything you've done.
Do you feel guilty?
It's okay now?
I'm tired of being shocked by people I care about.
Yes.
Okay, thank you. Okay, actually I told you, no, we have two set of codes in RISC-V. One is of 16-bit and one is of 32-bit, and 32i means it is of instruction. We will see. Okay, I just showed that this is the design. We are going to discuss one day. We will take a separate day for this, and now we will move on to the theoretical
That's the
part.
shift that Gujarat Giants was waiting for. It's happened in the last
Like,
couple of
Okay.
overs.
for SB,
Now, Meliaka.
Verilog code is available. System Verilog is available.
No, I will share.
Rare
I will
dot
share.
code that we've seen in the
We
last
have
couple of overs.
system Verilog also. See here, that is why I told we have two set of codes, and you
She's
can
done well
verify.
as Mealy Kerr,
No problem.
mixing
Like
it
for
up nicely, weighing the
32-bit
pace
only,
too. But
System
this will be
Verilog
a
code
big
is available.
challenge. This over will present a lot of challenges.
16-bit is
Yeah,
available.
in Actually, in Risk, we have many versions, we have many extensions. In that, we are mainly concentrating on Risk V 32i. That is 32-bit, which is of instruction is of integer part. We have many extensions, and I will tell you in the PPTs and all. I have mentioned that, and I will tell you the details. And we can do, no problem.
Some nice drifting, great bit of keeping. Just moved ahead in line, held still.
Okay.
But it's been a really
and my
good
PPT is visible now.
They needed to shift the Gujarat Giants. She's gone for 46, 142 for 4.
Okay. Actually, today we will start with the introduction of Risk V. Risk V means it is of ISA. ISA means instruction set architecture. Basically, instruction set architecture means to do a particular function or particular operation, we should have an instruction. Instruction means rules, how to do, and what are the frame format, and what is the destination address, and what is the registers, how many registers are there. Like that, we have some set of architecture, no? So that is ISA. So Risk is a part of that ISA. Okay, we have many ISAs. In that, Risk is also there. So full form of Risk is reduced instruction set architecture. In the name itself, they have told, no, it is a reduced instruction set. That means, see, there are two types, no. One is complex instruction set architecture. So in the name itself, we can identify that complex instruction architecture means that instruction set, you know, we have that frame formats and the procedure to do a process, no. For example, let's consider basically a add operation. Okay. So in order to do that add operation, we have some instruction formats, no, instruction set. So in complex instruction set architecture, it will be little bit complex. Why complex means that structure, that frame format, and how we are going to use that, it will be little bit difficult. Okay. But when it comes to Risk, no, it will be easier. We will see in the upcoming slides about that format and all, how it is going to implement. That way, we will see in the upcoming slides. So this is what Risk is. Okay, reduced instruction set means this is the reduced instruction set computer means this is the full form of Risk. What is it? Why we need to use? That is what Risk is. Okay. And it is developed in 2010. It is recent and it is open source. That is the main advantage. Open source means we can use, no, without any cost. We can take, we can use, we can fully, we can use that with efficiency. Okay, there is no more restrictions on that. Okay? Then what is the advantage? If they ask what are the advantages, means we can tell like it is simplicity. Simplicity in the sense, as I told you, no. Risk reduced instruction set. That instruction set is in simple way. Even we can easily understand, no. So that simplicity, scalability means that updation, no. We can easily see. Risk 5 in Risk means okay. 5 means it is of 5th generation. Okay, so that updation, no. So that updation, no, it is 5th generation, no. That is scalability. We can enlarge it. Okay, as per the generations. Okay.
जहां विमेंस टी20 लीग के मैचेस के दौरान जीतो टैब पे नए गेम्स खेलकर आप जीत सकते हैं ढेर सारे इनाम और MP2.
Okay, why Risk V? Okay, as I told you, no, it is free to use, no licensing and all. It is free of cost. And modular architecture means, see, we should be updated, no. Each year our SOC is getting updating, so based on that SOC our instructions should work, no. So that is modular architecture up to the trend. Okay, that architecture will be. That is why they are changing the architecture name as Risk 1, 2, like that. We are now using Risk 5, and it is simple and clean instruction format. Okay, what is simple and clean instruction format is? In the upcoming slide we will see the instruction format. That is in that 32-bit, no, in which bit what will come, like that we will see. Okay, that is simple and clean instruction format. Even when I am showing that PPT, no, that slide, you can easily understand. Oh, this is the format. Okay, this is what they have told, like simple and clean instruction format. Like that you will understand. And wide adoption means plenty of industries using Risk V nowadays. That is what they told. And it is mainly used in IoT, embedded systems, AI, like that. And see, this is some basic architecture. Okay. Okay, I will explain that. First, what it will do. See, in instruction memory, let's consider basic add operation, because it is basic, no, we can easily understand. No? So first, let's take some basic add operation. So for that add operation, we have a instruction, that is some opcode like 0110 like that. We have some opcode, no? That is stored in that instruction memory. Okay. Why 011 like that means? Because we all know, no, computer can understand only binaries, no? So in that instruction memory, opcode is stored. Okay. Opcode means what operation we are going to do and in which instruction extension it is. It is like integer or what extension it is and what is the function of it. Like we have function 3, function 7 and all. We will see, no problem. Like that, instruction memory holds that data, what we are going to perform like that. So obviously, then what is the use of instruction fetch unit? It is going to fetch that instruction, no? Actually, in our coding, in our Verilog design, no, we have these parts and all. We have separate blocks for this instruction memory, instruction fetch unit and all. And finally, control unit, no? After fetching that instruction, we will come to know, okay, what operation we are going to do, whether addition, subtraction, we are going to jump like that. We have, no? So, control unit will take care of that. Okay, before that, the data path, no, after fetching the instruction, data path, inside the data path, we have ALU and we have data memory as well. Okay. So, ALU, we all know, arithmetic logic unit. Obviously, it is going to perform. So, who is going to control that is control unit. Okay, that fetched data will be moved on to the data path and what operation we are going to do, no, that will be controlled by the control unit. Okay, so register file means if we have a like if basically in the adder we have 2 inputs, no, so that 2 inputs we need to fetch, no, so register file will have the 2 inputs. Okay, and based on that we can pass immediately also. We will see in the upcoming slides, like we have jump instruction, immediate instruction, register to register, like that and all we will see. So like that register will hold that, and data memory, you know, finally we need to, if we need to store something, if we need to store the operation or if we need to store our result for the upcoming functions, okay, upcoming operations and all, we can use that data memory. This is what the basic structure of RISC-V architecture. Okay. So as I told you before, the difference between RISC and CISC, complex instruction set computer, it is like, see, instruction set, this is important. Small and simple set of instructions. I will share this PPT as well, okay? You can refer. I will tell you now, and you can also, in later times, you can also use this for preparations as well, okay? So, small and simple set of instructions, and in CISC, no, large and complex set of instructions. So, see, CISC have its own advantages, okay? But since we are looking for RISC right now, we will make some advantages in RISC side for our preparation, okay? So instruction length, it is fixed, typically 32 bits, but see, RISC 32I means we have 32 bits, but RISC 64I also there. So in that case, our instruction sets, that length, you know, instruction length, it will be of 64 bits, okay? So instruction length will be fixed, but in CISC, no, variable 16 to 64 bits, it may vary. And one more thing is, they have, what they told here is fixed, typically 32 bits. What it means, we also have 64 bits, but when it comes to that particular function, no, when we are going to perform some particular function, throughout that operation, and but particular type RISC 32I, know, so for every instruction it will be of 32 bits only, but in CISC it is not like that. It will vary from 16 to 64 bits like that, it will, and it will keep on, okay? So execution time, one instruction per cycle, and instruction in CISC side, instruction take multiple cycles to execute. And see, here also one thing is like in RISC also we have single stage, 5 stages, okay? In 5 stages, it will take a particular time for each stage, and we have pipelining concept, no, like fetch, execute, and all. So we have that 5 stage, no. In RISC also there is 2 types. One is RISC-V single stage and RISC-V 5 stage. Right now we will see single stage, okay? But 5 stage is not difficult. We can explain like 5 stage means it have that we can explain that pipeline architecture. In the upcoming slides also we will see what is pipelining and what about that architecture and all. Okay, then decoding, simple decoding. Decoding in the sense we are going to decode the data now. So it will be simple. In where we are going to do means in data path, no, we will see in code as well. Okay, we have our binary code like 0, 111, like that and all we have no. So it will be easily decoded. That is what they are telling here, and the decoding will be performed in the data path unit. Okay, we will see when we are coming to the Verilog part. Okay, then pipelining easy to implement due to simple instructions, and in CISC side it is difficult because of that complex instructions. Okay, and hardware requirements, more registers, simpler control unit. Okay, yeah, we need some more registers, no, because we have simple only, but okay, we will see why we need more like that. Okay, here in CISC side we need fewer registers and more microcode. Microcode means some complex code, deep code. Okay, in control unit. Okay, code size is larger in RISC. As I told you, no, see, CISC also have its own advantage. Okay, and what are the companies using? We all know, no, RISC is basically using in plenty of companies right now. And as I told you, no, there are some extensions. See, extensions we have. If we have RISC V, I know. Wait, I will show you. See, here, like that. See, we have R type. R type means register to register operations. I means immediate operations, like that. It is a part of the RISC-32I. Okay, inside that, if we consider RISC-32I, I means it is of integer. Okay, so inside that we have this extensions and all, like M means multiply, divide, and A means atomic. Maximum we don't use it, but for your reference, just learn about, have a knowledge on that. And F means floating point, and D means double precision, C means some compressed, and V means vector. Okay, these are some extensions inside that. Okay, inside that instructions we have some extensions. For these extensions, no, there are some particular codes like function 3, function 7 and all there. We will see in the Verilog code there. Okay, base ISA. This is what I told. We have some extensions also. Extensions means in C. RISC V RV32I. What it means, RV means we all know. RISC V 32 means 32 bit of instructions, and I means its base is integer. Okay, integer instruction set. What it means is we are going to perform some integer related operations. Okay, then you may ask me like, okay, then what about if we use some floating or like that? What we will do? Like that, if you ask me, we have some other extensions. Okay, if we have RV32I means it is particularly designed for this integer instruction set. But if we need to use some floating points, no, for that we have particular like RV32F, like that we have some extensions. Okay, that is what advantage of RISC V is. See, it is like particular and precise. That is what. Okay, based on that we have like RV32I, RV64I, RV128I, like that. I think you can now decode like what is 64, 128 and all. And if we need some extensions, no, see, as I told you, no, for floating point and floating point and all, we use F. Okay, instead of RV32I, we use RV32F, like that. And for double precision, we use RV32D, like that. We will use based on our requirements, what operation we are going to perform, like that we will build our structure. Okay, right now we are going to build RV32I, and we have one more code, RV16-bit. Okay, and as I told you, in the starting itself, we have two codes for reference. You can one code you can use it for Verilog, and one code there is it is with system Verilog, that architecture. Okay, for verification you can use one code for that. Anyway, you are going to explain in interview time. You can if you have the knowledge of those two codes, means you can somehow manage. You can easily answer. That's why I have two set of codes. Okay, then RISC V base ISA. This is what we are going to see right now. Okay, RV32I. RV32I, you know what it is. And see, 32 general purpose registers. It is different. Okay, register is different. Our instruction length is 32 bit, and we apart from that we have 32 general purpose registers. Okay, And see, you may ask like, okay, if we have our instruction like add R1 comma R2, then what we are going to do to convert that into binary means we are going to do some we are going to have some assembler. Okay, assembler means it will going to convert that assembly language to source code, because someone may ask, no, in interview and all, what is the use of assembler like that. Okay, so in that case we can answer like it is used to convert our assembly language, that is source code, to binary code. Like that we can answer, no? Okay. Okay, then see, in floating point register, no, I have mentioned here, no, see here that extension we use F. Okay, so for that we have 32-bit floating point registers. Okay, so it also have, for each version it have some particular register. Okay, you know what is the use of register? For storing purpose. So for floating also there is 32-bit registers, 32-bit, no, 32 registers, particular registers. Okay, general purpose registers.
In that chase, but
okay.
61 has been scored in those
last based ISA, and we can load and store architecture. We all know, no, what is load. We are going to load some information, and after doing some particular operation, we are going to obviously to store, no. So for that loading purpose, in this in this architecture, no, for loading purpose, what we do. Okay, we take some addition example. Okay, so addition, there are two inputs. What we are going to do, we are going to load that, where we are going to load in the register file. Okay, so in that register file we are going to load. So we are going to so that is load operation. So if one of our output is like we are going to pass immediately, means what we are going to do means we will we use for that also we have extensions like register to register, immediate extension. We will see in the upcoming slide. So in that case, we store one of the input from register side, and one will be a immediate input. Okay, and finally, after getting a result, if we have some use of that result, means we need to store it some place, no? Store that result in some place, no? So that purpose is that data memory. Okay, that is store operation. Okay.
So I'm sure that she carried that confidence, knowing the bowlers.
Okay, still now you have any doubts or anything like? You can ask, no? Is there any doubt still now?
A little bit time, and then that 15th over probably has changed.
Hello, no doubt, sir.
The momentum for them to get those big shots going, and
okay, then we will continue.
No, but sir, can you please go a bit slow?
Okay. That's why I asked it. Sure, I will go slow. No
she
problem.
adjusted well to the spin. We saw her use her feet a lot, and she
okay,
was
then.
clear around
See.
the over that she wanted to
It
target.
is. So from here only we are going to study the actual thing. Okay. Anyway, you are going to put in your resume like RISC-V processor, and you are going to mention, no. So this is the actual thing. Okay, RISC-V 32i, and you can also mention like RISC-V 16-bit like that based on the code. Okay. We have two set of code, no? Based on that we can. Okay. As I told you, no, before, instruction formats. These are the instruction formats. Okay. Extension is different and instruction format is different. Okay. Extension in the sense we have like for integer we have I extension, for floating we have F extensions, like that. Okay. Extension means what that at particular RISC is going to perform, which operation it is going to perform. Inside that extension we have some instruction formats in the sense in what format we are going to feed the input and in what format we are going to load. Like that we have some formats, no, that instruction formats. There are some types like R type means register to register operations. Okay. See example add subtractor, no. In every operation we do add subtraction. Okay. Immediately in that immediate instruction format, no. In that also we can use add R2 or add R1 comma some immediate data. Okay. So I in the sense I type means immediate operations and loads. Okay. And S means store instruction. See when it comes to interview, no, we can tell this as a point. Okay, in my project I have included like we have some instruction formats, R type, I type, like that you can, and I used extension, I extension, because of my instruction is used for some integer based operations, so I used I extension. Okay, they ask like what about F instructions and F extensions and all. If they ask me, so you can tell no. In our project we used this I extension alone. Also, we are familiar with this I extension. This is our project, like that you told no. So for that purpose only, we need to know that what are the types of extensions and what are the instruction formats and all we need to know. Okay, for that purpose only, some knowledge. Okay. Okay, then see, branch means, let's consider we have a basic addition operation we consider. In our actual project we have some we may have some complex instructions also, but for our understanding no, in the basic level we can take that addition operation itself. In branch means, let's consider there is two address. Okay, one of the address, basically what we have add, and we have two inputs. Two inputs will have two datas. Okay, as of now it is clear, I think. Add, and we have two inputs. Two inputs will have two datas. Okay, so two datas, we add that two data and we store in the data memory that final result. This is what happening. But when we use branch, no, what happens is one of the input will have the address of another location. Okay, so that another location will have the actual data. This is what branch is. Conditional branch means we have some branches. Branches means we have some different location. In that location we have the actual data. Okay, and we have upper immediate. Immediate means we pass. Upper immediate means what? We have 32 bits now. In that upper bit, if we need to include something means, if we need to add some data, we need to change some data means, or we need to load some data, we use upper immediate. Okay, and usually you know no, jump and unconditional jump and conditional jumps are there, no? So what is this jump format is of, if there is a instruction, after completing that particular line of instruction, we are going to jump to some other instruction, some other location. Okay, so there we may have some data like that and all, no? So that in that case we use this jump. Okay, jump formats. Okay, see, as I told you, know, these are some set of examples what we are going to do like that. Okay, load word, that is we are going to load no immediately. See here, actually here register type in the sense all the three are going to be registered. Actually here x1, x2, x3, no, these are registered, but in actual case we use r1, r2, r3 like that. Okay, you will see in the that format, we will see in the upcoming slides and all, no problem. And load word means what here, what we are going to do means, see, x1 means R1 first register, we are going to load some data means we are that immediate data. Okay, that is I type. I type means see 0 is there, no, we are going to immediately load something. So R type means register, I type means load, I type means immediate, and S is for store, and B is branch. Okay, so there is a label, no, in our instruction. I think you are familiar with that instruction. Usually if we write a group of code, there is in the particular line. Okay, if we have a group of line means in a, if we are doing some particular operation, there will be some set of lines. Okay, in the particular line we mention there as label. Okay, so and one more line we mention as label. So when that particular line comes, no, it will directly move to that place where you mentioned as label. Okay, this is branch. We will see, I will explain, no problem. Branch means it will move to another location. It will branch to some other location when the particular instruction, particular line comes. And if you use that branch means, branch format means, it will going to redirect you to a particular location. Okay, so in that location you will have the actual data which you need. That is what branch is. Okay, yeah, and in branch we have branch if equal, we have some types like that. Okay, So see here I'm just giving you some clue, okay, what it will be and what are there, and like that I will give some clue, and this PPT is like that only, and you need to search something from yourself also, okay. So like if we have here branch type means what is branch type, what are the types inside that, like that and all, there are plenty, okay. But for our concept, for basic and what we are going to include in that design, no, for that this is enough, but there are many things to learn, okay.
It's easy to talk about forgiveness.
Okay.
Sir, these instruction sets are equal like a microprocessor as we write in there.
Yeah, actually in 80, 86 and 85 there are no microcontroller, microprocessor. We use this instruction, but okay, see, this is same only. You are also, I think you come up with some microprocessor or microcontroller in your previous day. You may see this type of instruction like add and LW like that and all, no? But see, this is just what they tell me, mnemonics, like this is just a assembly language. But what RISC is like, inside that, no, after moving in deeper, okay, this instruction, no, there is some format, no, wait, I will show you. This is for, see this format, no, opcode, RD, function 3, RS1, RS2, function 7, like that and all there, no. So this is what that RISC is of. This one is, you may see in many places, many microcontroller, microprocessors like 8085, 8086 and all there, no? You can see this similar instructions there, okay? But inside that instruction, no, how it is going to perform, how that instruction is going to be fetched, and how that instruction is going to be feed to our processor, and inside what are the things going to happen. That is the RISC, okay? This is overall. We should know this also, but how it is going to happen, that is important, no? See, wait. In this coding, see, in this coding, no, that add is okay, it is no problem. But when it comes to this coding, there is data memory is there, no? So after fetching the data, we go to this controller. See here, this operation, no, 11110, and this there are some opcodes, no, like function 3 and ALU opcode means arithmetic logic unit. There is some opcode. So inside how it is going to happen, that is what RISC is. And okay, I think you can understand, no? Who asked me what is RISC of that add and all? It is, yeah, it is mnemonics. You can see in many places that similar thing. You can understand, no? Now
8.5 runs and over.
Hello?
Yes.
Okay. Who will play next Tuesday?
That is what I told, like.
So it is all on the line for these.
So why using RISC we only do the ALU operation or what kind of?
That is, I told you, no, that's like it is based on the extension, okay. So for that we use ALUs used to not only see what we learn is ALUs for addition, subtraction like that, but using that only we are going to perform many things like shift and for jumping. We have control unit for jump and all, but ALU is for shifting, addition, subtraction, whatever. We are going to use ALU only. For that ALU operation alone, okay, that is important. For if there is ALU operation, then for that we use ALU block, okay.
Myself to manifest my best life. Nature's cosmic energy. Now mine.
In that, there is function 3, no? Function 3 means in our frame format. See here. In our frame format, there is a function 3, no? So it is of 3-bit. So we have some code like 001. Then it move to some place. There it will be like addition. 011. Then it will be like subtraction, like that and all. There will be, okay. So for that purpose alone, we use ALU. Okay. So see, when we move to ALU, see here add operation, OR operation. Basically, this is what ALU know. What we know is addition, subtraction, but multiplication, division. But apart from that, it has plenty of operations to do. Add, OR operation, AND operation. Based on that, we have many. See that basic logic gates are used for some advanced level also, no? So that is what we use of ALU, okay? It is based on the extension what we give, okay? So it will change according to extension, but all the operations are going to perform only in the ALU, okay? Not only in some control unit. If our control unit needs to do something, no, like branching and all, then it will take place, but majority of operations will be on depend on ALU only, okay? That is what this risk is of. We are going to do some operation which ALU is the main thing. Anything like shift left, right, if we need to check some equality, like equal to or not, greater than, for that purpose we use ALU, okay?
Swing bowlers in Kashfi Gautam and Renuka Singh Thakur. They can't afford to do that tonight.
Okay,
they've got to try and
there
make
is
early inroads.
R-type, as I told you, there are some frame formats like R-type, I-type, S-type, B-type, U-type and J-type and all. So for that, this is the frame format. So frame format in the sense, it will have what are the operations, that particular bit, what are the group of bits will do, like that, and all there is some information, no? That is frame format. For RISC 32I, there is 32 bit. It is a 32 bit instruction. So that 32 bit, in each bit, no, there is some use case. Use case in the sense, see here, for opcode we are going to optimize 0 means there are totally of 7, okay, 7 bits. Wait, we will check here also, no problem. In instruction memory unit, no, see here, there are likewise here we have plenty of ports, okay. In that, this is the instruction, okay. It is of 32 bit, okay. That is why 32H. It is of 32 bit, and in the first 7 bit will be considered as opcode, okay. So where you can see means, wait, see, you can see in this controller, okay. So we will see in the design, okay. This particular opcode comes means what will happen, like that and all that, okay.
Just a little bit, and that's.
So, like that, for RD means destination register. It will take around, like, it will take around 5, like that, it will take some bits, okay? It will take like that, and function 3. See, function 3 means we have some functions like add, subtract and all, no? It will come under function 3. So function 3 will have some binary codes like 001 means add, like that. Right now I showed you, know, that example, that actual design. There the function 3 will mention like add means 001. Then it will go to that, after that if condition, we use if condition. After that if condition is satisfied, we move inside that, and there will be the particular operation, okay. This is what this function 3 are. And as I told you, know, there is 2 source registers, RS1 and RS2. See, it is design is ours, okay. If our actual operation is complex, our design also increases, that complexity also increases, okay. We will customize according to the design, okay. But we follow that standard rules, that ISA, okay. And function 7 also, it is opcode, it is of 7 bit, okay. It is also same thing, it have some functions, okay. For this binary code, this operation should be done, like that. It have some works, okay. So then immediate operations, immediate operation, you know, no, we will pass our inputs immediately. Immediately means without fetching from some registers and all, we will pass immediately, okay. And see, for each frame formats, okay, for each instruction formats, that frame format, no, it varies, okay. For R type it is different, for I type it is different. So yeah, there may be some similarities, but it is different, okay. We should not use same format. Then see, for I type we have different opcode, okay. And here also we have destination register, we have function 3, and we have one source register. And I think you all know like why we are using one source register one, because another one is like immediate, no. So one data is from immediate and one data is from register, okay. So that's why we use only one register, only one source register, and we have immediate value, okay.
mean, it's disturbing, but it's awesome.
Okay then. See here the bits you can notice, no? 6:0 means upward and 11:7, and here you can notice like 0 to 32, 31. Okay, so our instruction here wherever you notice means our instruction length will be of 32 bits. Why 32 bits? Because of our this RISC-V type RV32I. Okay, so that is why it have 32 bits. And see here we have some registers, like we have saved register, we have temporary registers and all. And when we move more deeper into it, we will learn about it. Okay, as of now for our project it is okay. Okay, but if you want to learn, you can learn more deeper. Okay.
I think both bowlers are pretty
Okay,
similar.
then we can move to next one. That is store instruction. Okay. So store instruction in the sense here also the frame format will differ. Okay. See for opcode length, everyone for every extension opcode is same bit. Okay. It is going to consume up 7 bits. Okay. That's all. And here we are going to pass some immediate bits. Okay, then as usual function 3 will be there. Then we have two set of registers, RS1 and RS2, and that registers, no, both registers will have same bits. Okay, in some case it may vary, but maximum if we have two registers means it is of same size only. Okay, then we have immediate bits. Okay, you know, no? Now only we saw no what is immediate is of, like that. And here branch type. Okay, see for branch type here we have two immediates. Okay, two immediate bits, and one is for branching. Okay, here you can see, no, like branch offset. That means it have that offset address. Offset means in that particular immediate bit we are going to pass some data, but it is not the actual data which we are going to involve in the operation, in the function. Okay, that immediate data which we feed to that immediate 11, no, immediate bit 11, there are 11 bit, there is immediate bit 11, no, that branch offset. The data which we are going to feed to that branch offset is address. Okay, so base it will move to that address. Okay, once that immediate address we pass, that immediate address means so that address have some data. Okay, then it will be branched to that address, particular address which we have mentioned. Okay, so from that address we have the data, so we fetch the data and we do the function which we need to do. Okay, and here we have two immediates in the LSP level. Okay, LSP level we have two immediates and we have function 3. Function 3 is something like fixed. Okay, wait, I will show you.
In the end, she's just letting her hands go for nothing.
See here, this is opcode, and when we go to ALU,
comes lower in the order, got a good
see,
innings,
this
and then
is
is
ALU
pushed
select
up
line,
to play
and
the swing
then
ball.
where is ALU controller? Okay, here. See, there is a function, no? It is of 3 bit, and ALU opcode we are doing some concatenation here. Okay, I think you can see here. No? We are going to merge our function 3 with ALU opcode. See, both are same only. Okay, we no need to confuse, and we are forming this RISC based on our need. Okay, we can customize it also. Okay, if you need to customize, if you need some more good means, you can customize. Okay, that is what RISC-V, but we need to follow that instruction format. That is important. Okay, so here you can see now this opcode. This opcode is same for all formats. See, in this total block there is nothing mentioned like it is for R type, it is for immediate, it is for jump, like that and all. There is nothing like that. Okay, opcode is this function 3 is common for all. Okay, just we need to mention if we have a space in our format, we need to mention what it is going to do, like that. Okay,
I quite like this from Ash Gardner. Only 8 on the board.
So this function 3 we see, no, this 3-bit opcode. Okay, then RS1, RS2, you all know that it is of register 1 and register 2. Then we have immediate. Once again we will pass. See, there is plenty of use in this. Okay, we can use based on our needs. Okay, for what purpose we need, that is important. Okay, so then U type in the sense, see, upper immediate. Upper immediate means in the name itself it is there, no, upper immediate. That is, we are going to pass some immediate value in the upper bit. Upper means that MSB level. Okay, that is what upper immediate is. Okay, so it also, as I told you, same opcode and it have some destination register. Then we will pass the immediate value. Then finally J type. Okay, so J means we all know, no, jump. What jump means? From one place to another place we are going to jump. That is, our instruction will be jump to another place, another line. Okay, we may have some information in that line. It may fetch that information and it may redirect to some other locations and all, no? So in that case we are using this jump. Okay, in jump also, as I told you, that same opcode and we have same destination register. We have immediate. Okay, we have immediate bits. That's all. Okay, here we no need to involve some registers and all.
Like it in the sense that they've restricted the Mumbai Indians.
Okay, as of now, you have any doubts in this frame format? Any doubts? You can refer. I will share this PPT as well. You can refer in your free times after completing this session also. But as of now, in this session, is there any doubts?
That's a better pace. 74 kilometers
no doubts,
an hour.
If you have any doubts, we can ask till now.
That 80 kilometers an hour.
Sir, here there are so many immediate. So what?
In the power play, of course.
So what is this purpose of like immediate bits 19 to 12? Can you please explain that?
Okay. See, in some case, what we do, we need to in some case we need to immediately pass some value, some data. Okay. So for that, we can use some, here there are plenty of immediates, no? We will use one of the immediate. But there are some cases, no, where we need to pass our immediate, that is, we need to pass our immediate address and we need to pass our immediate data. So that immediate address, no, it will be moved to some immediate location and we are going to pass some immediate data to that location, like that and all. See, in based on our needs, in some places, we need to feed some immediate data, immediate address and all. So, if we want to use immediate in more than one case, like as I told you, in some case we use only data. We will feed data as the immediate. In some case, we need to pass immediate address, in which address it need to be, or in which address it need to jump. Okay. See, finally we have destination. Okay, we have some destination. Let's for your example, let's consider like we have RD. Okay, and we have some immediate data like 0x01. Okay, for our example 01, like that. We have some data like 1. Okay, that 1 needs to be passed to some immediate address like 0x02. So that 0x02 will be passed to the RD. Okay, so the data inside that 0x02, that address, immediate address which we passed. Okay, so inside that immediate address we have our immediate data. For example, I told 01. Okay, so that 01 will be passed to that destination register. So here in my case, in this example, we are using two immediates. One is for immediate address, one is for immediate data. Likewise, there are some cases. In some case, you only need to pass some immediate data alone. So you will pass some immediate data and directly to the destination register. But in majority of cases, we have immediate address, immediate data. So in that case, no, we will use this immediate. We have this many immediates. We will use according to our use. Okay, you can understand, no? Now you can understand it.
Perhaps it didn't go well for DC. The seasons when they had a direct entry
this is
into
what
the finals
frame format is. Okay,
because Mumbai Indians played the eliminator and walked into the final.
Okay, then pipeline.
Quite timed.
Okay. See, pipelining means what?
From the Gujarat Giants,
We are going to so as they told, to improve performance. How we are going to improve performance? Somehow our instruction need to work faster. Okay, so how it will work faster? We need to execute the instruction more than one instruction at a time. Okay, so how it is possible? It is possible because of pipelining. Pipelining in the sense, see,
right now.
Here, let's consider like we are having an instruction. Okay,
you want a chance to experience
it need to be passed through 5 stages because pipelining have 5 stages, no? Fetch, decode, like that. Right? Here we have 5 stages, no? Instruction fetch, instruction decode, memory address, and write back, like that, no? So, see, let's consider this as instruction fetch. Okay, here we can consider this one as instruction fetch. Okay, there it is. Okay, we will consider this as instruction fetch, and one will be instruction instruction fetch, and this one will be instruction fetch, instruction decode. Okay, and this one will be the execute. And this one is for, let's consider this as memory access. Okay, and finally let's consider this as write back. Okay, so we have 5 stages. Let's consider we have 2 instructions. Without pipeline, what it will do? If we have our instruction 1, okay, what it will do means first go to this fetch stage. So we will fetch the instruction, then decode stage. Okay, here we are going to decode. Okay, here it will take some time, and here it will take some time, and after decode it is going to execute what is the operation is of. Okay, and after passing memory access. Okay, because for execution, okay, for execution we have some registers. After that we need to access, no, for store or load, like that. So for that memory access, and after that write back in sense that result. We need to know, no, what the result is there, right? That is called write back. Okay, now our first instruction is over. Then our second instruction is here. What it will do? Once again, it will move on to all these 5 stages. Okay, like instruction fetch, it will go. Then it will go to instruction decode. Then it will move to that instruction, that execution stage. Then it will move to memory access. Then it will move to write back. Okay, this is non-pipelining. Okay, after completion of one instruction, it will move on to the next instruction, and next instruction will follow the same cycle. But when it comes to pipelining, no, see, our first instruction will be here. If it is in instruction fetch, then our first instruction moving to instruction decode, our second instruction will come to this fetch stage. Okay, then after this first instruction moving to this execution stage, our second instruction will be in this instruction decode stage. Okay, then after our first instruction is moving to this memory access stage, our second instruction will be in this execution stage. Okay, this is what pipelining is. Okay, so they also tell like this only, no? Pipelining is a technique used in CPUs to improve performance by overlapping the execution of multiple instructions. Okay, so there are 5 stages, as I told. There is instruction fetch, that is to get the instruction from the memory, and there is instruction decode, that is we are going to decode and we are going to read the register. Decode in the sense we are going to decode like what that instruction is of, like that we are going to decode. Then execution, perform arithmetic or logic operation. We see, no, in that ALU block we see, no, in that code. Okay, this is comes under execution stage. And then we have memory access. So memory access in the sense we are for read or write we need some access, no, from memory, that is memory access. and then we have write back. Write back in the sense result. Somehow after completing, we need to get the result now, that is write back stage. Okay. These are the 5 stages of pipelining. Okay. And our risk, we know it will follow the pipeline, but here in our project, no, there is of 2 things. One is risk V single stage and risk V 5 stage. Right now, we are going to see risk V single stage. Okay. Single stage in the sense at the clock cycle. Okay. In a single clock cycle, it will do all the operation like instruction fetch, instruction decode, execute, memory access, write back. All these 5 stages will be done in a single clock cycle. Then see how big that clock cycle will be. This is what single stage. And 5 stage is somehow difficult, somehow complex. But when we use 5 stage, each clock cycle will take some small time. Okay. Because small operation, instruction fetch, it will take some time. Instruction decode, it will take some time, like that. But when all this 5 stage is done in a single clock cycle, means definitely it will take some big amount. That is what, that in that single risk V, in that single stage, it will take some extra. It will take some, that clock cycle length will be high. Okay. Then advantage. Okay. Advantage of fixed length instruction. Okay. Here I told you, that like risk V 32-bit instruction. Here what is 32-bit? We all know, starting itself we discussed, 32-bit means our instruction length will be 32. So it is fixed throughout the operation in every operation, like this particular risk V 32 I know. So using this particular extension in whichever operation we perform, okay, the instruction length will be same. So what is the advantage we see to decode? Because if the instruction length vary means we need to create according to that length. Okay. We need to create a decoder according to length. So in that case, we need to create different decoder, or we need to customize something, okay, inside the decoder. But when we have some fixed length, it will be easy to decode, and the same decoder will be used, So that is what they are telling. And every instruction is the same size. Okay. The CPU can fetch and decode instruction faster because it knows exactly where each instruction starts and ends. See, this is the most important thing. Okay. When we are passing some instruction, it will take 32 bits. Then we can easily identify, okay, what will be the next address location will be. If the instruction length is same, it is easy for us to understand what is the location, what will be the next location, and what will be the next location. That calculation, it will be easier for some fixed length instructions. Okay, that is what we used in this risk V. Okay, then as I told you, we no need for some extra logic to configure out instruction length. Why we no need any extra logic? Because of same size. Instruction is same size, Then why we need extra logic? We no need any logic for instruction according to this instruction length. Okay. And okay, we saw some pipeline architecture, So simpler pipelining design. Okay, see, I can explain, that simple it is. Okay, and fixed size means instruction fetch decode hardware is simpler and more predictable. That is, we can easily predict. Okay, next to this location. Next after this particular instruction, our location will be from this. It will start from this location. And it will be in this location, like that. Okay. And easier to calculate the next instruction address. Okay. That is what I told. Then better performance. Then faster instruction fetch and decode because of reduces pipeline stalls. Okay. Okay. Then we can do something like in next session, we will see, if possible, we will see like what is stall and bypass. You can also refer. See, stall means, what stall means, if there is some instruction, okay, so it is performing, some instruction is in act, it is performing. So stall means that stops. If we need some, if it takes some time, means we need to stall, that particular place. That is what stall. Bypass means we will cross that and we will move on to the next process and all. Okay, that is what stall and bypass. Stall means if there is an instruction and if that instruction is performing, and if it takes some time, we will stall that. Stall means the next instruction will wait until the particular instruction completes its operation. We will wait for some time, and then next instruction will be performed. This is what stall, that is wait. Okay, it will wait. Or it will stop. It will not stop, it will wait until that particular instruction is completed. Bypass in the sense, if there is an instruction, it is performing, and if we have another instruction, and it will not wait. What it will do means, instead, it will bypass. Bypass means it will cross that particular instruction, and it will do. That second instruction will do whatever the operation it wants. Okay, that is what bypass is. Okay. You can also search in Google also what is meant by stall and bypass. It is important, no? As ma'am told. And simplifies instruction alignment and memory access. How it simplifies? Because of this same size. Alignment is easier, no? If we have same size, that is it. And some real world applications. Yeah, you are all familiar with this, no? Nowadays, many companies, not only the companies listed here, many prefer RISC-V because of the previous sites. We see, what are the advantages and how the frame format is of, and it is open source. So we have many advantages. So many companies preferring this. And core for microcontrollers and custom processors. Yeah, actually, even now in our session, someone asked, this instruction we have seen in some other place like that. Many microcontrollers will use this. So it is made of RISC only. Okay, that mnemonics maybe it is from it is same, but inside that our instruction set may vary. But RISC is almost similar. Okay, RISC is used in some majority of places. Okay, and growing ecosystem is it is keep on increasing. No, that is what this and all some applications. Then conclusion. Okay, then we whatever we discussed now, this is what they told here, like offers flexibility without the cost of priority ISS instruction set architectures and ideal for academic projects. Yeah, even in our projects we can use RISC-V. See, then this is what the advantage, and in some startups and large scale industries as well. Okay, so as of now, is there any doubts for you? This is what theoretically, but here you may have some doubts. No, as of now, if you have any doubts, you can ask. No, as of now, is there any doubts theoretically? Coding also same only. What we discussed here, we will see in code which block and what is the use of that block. Like that, we will see. So as of now, do you have any doubts? No doubts, huh?
No.
Okay, see here in design, no? There is of two parts. Okay, see here we did our design, and this verification is of system Verilog. Here we here we have our design, and it is of 32i, but this verification is made of Verilog. Okay, simple only. Okay, what you can do is you can use this design for your explanation, and we can use this one, this structure, no, like how we pass our inputs and all. We can use this for our explaining our verification. Somehow we are going to see this one and this one, but in case of interview, if they ask me, you can use this design, and for explaining that verification process, no, that structure, for that you can use this. Okay, or else from my side, I will try to take the verification environment for this also. Okay. Okay then. So as of now, is there any doubts for you? If you have any doubts, you can ask. See, I will take 3 days for each project. Okay, 1 day is for theory, and 1 day is for design, and 1 day is for verification. Okay, so there are 2 projects from my side. Okay, one more project you have linked, no? So from my side, I have 2 projects. One is router IX1X3, that is 1 source 3 destination router, and one is this RISC project. And I will take theory 1 day, design 1 day, verification 1 day. If we can't complete, we may extend to 1 more day also. Okay, but we will complete within this week. This is what our plan is of. Okay, if you have any doubts, you can ask.
Sir, at what time this will happen?
Okay, we can keep, see, this is weekend, so no problem. In weekdays, you may have some work, no? So in that case, we can have our session from in night time. Actually, are you available in morning time here?
No, sir. Morning not possible.
Okay, that's why we can have night time like 7:30 to 9:30 like that. In night
Yeah,
time we have. That time you
yeah,
will be free, no?
yeah, that time.
Yeah, that's why I'm planning to take the sessions, upcoming sessions in night time. So, in if it is weekend, anyway, this day alone is weekend. So upcoming we will finish in the next week itself. Okay. So we will have session from 7:30 to 8:30 like that. Okay. In night time we can have. Okay.
Okay, sir.
Okay. Sir, any other doubts till now what we
No,
have discussed?
no, sir. Can you please share
Okay.
the PPT now?
Yeah, I will. I will send PPT and if possible, I will share some other outsourced documents as well. You can refer no for that purpose. I will try to share. And now I will share the PPT. Okay, you can have. Okay, if you have any doubts, you can ask or you can leave. Thank you. Bye.